thing I would like to say is that I would like to draw attention to one thing, that English was the only language of the conference today. And of course, it makes things a lot easier as far as discussing with foreign colleagues is concerned. But without any jingoism of any sort, I just want to remind that the diversity of language is an issue that should not be overlooked. Let me go back to Serge's example this morning. He said that, computers have problems to distinguish between cats and dogs. But just think how difficult it would be for a computer to invent an expression like "it's raining cats and dogs." So I mean, that's one level up. And I think it's important to realize that languages are not only neutral tools of communication that we can use in very specific contexts like today's conference, but there are also works in progress, and that this diversity makes it possible to realize how situated languages always remain, and how we have to constantly transform them in order to keep them collective. So that was my first remark. The second remark I would like to make is to go back to Gregory's talk. And so his idea was to trace back today's transformation of legal systems to the project of Leibniz, and that goes back to the De Arte Combinatoria of 1666 that Leibniz developed later in his career. And he said that we have now means to have a more muscled Leibniz. I'll try to question this because I think that Leibniz project was never fully carried out, even if it was some kind of ideal that remained in his life, and he would go back to it throughout his career. So I think this is important to remember, and I will show why. So what was important in Leibniz was the idea of the expansion of knowledge. And as you mentioned, Gregory, this expansion of knowledge was possible through two concepts. The first one is encyclopedia, and the other one is characteristics. So in brief, by sticking to the written characters representing ideas, which is characteristics, and by using the rules of formal logic only, it would be possible to derive new consequences from this set of characters, and therefore to expand knowledge, encyclopedia, in an absolute objective way. Let me change this. Oh, it doesn't work. Okay. So we'll do like this. Okay. So yeah, the project of Leibniz was not carried out entirely. And even if today Leibniz encyclopedia is called big data and characteristic is called computation. So I will try to explore these two notions further in the context of legal systems, and I will try not to forget that even the great Leibniz never managed to achieve this goal. So first, big data. So what's the idea, as far as I know? So I will first start with a quote, which I believe is very typical of the big data viewpoint. And the quote is by Chris Anderson, the editor-in-chief of the American magazine Wired. In an editorial published in June 2008 called The End of Theory, Anderson argued that science, in its endeavor to explain reality, no longer needs theoretical models, but only statistical correlations. So I will quote it in English. The scientific method is built around testable hypotheses. These models, for the most part, are systems visualized in the minds of scientists. The models are then tested, and experiments confirm or falsify theoretical models of how the world works. This is the way science has worked for hundreds of years. But faced with massive data, this approach to science, hypotheses, model, test is becoming obsolete. There is now a better way. Petabytes allow us to say correlation is enough. We can stop looking for models. We can analyze the data without hypotheses about what it might show. We can throw the numbers into the biggest computing clusters the world has ever seen and let statistical algorithms find patterns where science cannot. So the automatized research of correlations between data we can explore through brute computing force is supposed to replace scientific knowledge and its slow semantic understanding through testable models. So in other words, correlations are sufficient to predict the future and to act accordingly. So let me take a very simple example of this new viewpoint. When we try to translate a text in a foreign language, we use dictionaries that help us find the best possible meaning. And we all know that translating is highly difficult and it's a semantic task. Only some of us can achieve in a good way. Of course, there's another more technically advanced approach, which was devised during the Cold War, when the strategic goal in the West was to translate every Russian sentence available. And this is the idea of artificial intelligence, at least at the beginning. So the idea was to try to build up automatic translating machines by finding the logical description of concepts and the rules that professional translators were supposed to follow, and by implementing them in algorithms that computers would then process. The results, even though promising at that time, never met the expectations, and the projects were, one after the other, abandoned. Even though, I must say, AI had announced time and again that automatic translation was within reach. So it was some kind of revenge of semantics over a mechanized approach to translating. But this is not the end of the story as we know now. There's now a new approach, the big data approach, that most of us are using, sometimes even without knowing it. When I want to translate a French sentence into an English, I get stuck. I copy the sentence to an online dictionary, paste the sentence, and wait for an answer. The online dictionary doesn't try to make any semantic analysis. It only correlates my sentence in French with the best possible match in a text that is marked as belonging to English. Usually it means that the dictionary will end up in an official Canadian website where all the texts are given in both languages. And most of the time it's irrelevant, but very useful sometimes. So the online dictionary is only a correlation engine that relies on the semantic work already done by human translators that can be found on the internet. This is, I think, how big data work. By sticking to formal characters and some correlation algorithms implemented on machines, it leaves the semantic work to us as a collective intelligence. And this is what Anderson was talking about. No semantic models, no science, just correlation through computation, and that's enough to predict and to act. This has big consequences on science, of course, which was up to now a quest for semantics, causation, and not a quest for formalism and correlation. But does it really work? So is it really Leibnizian? I will argue that this approach has intrinsic limitations that should be spelled out before getting to the way big data are used in legal systems. So my second point would be correlations are not enough. There are at least three main types of limitations that shatter Leibniz projects and that should be examined when we are dealing with computation and big data today. The first one is limitation in categorization. the way concepts are formally represented by characters. There is no fixed representation that can be unequivocally connect characters and the semantic notion it refers to. Think of the rain and cats, cats and dogs rain example. So there is a drift in meaning which is everywhere in natural languages and is instrumental in making languages situated but also versatile. So that's the first limitation. The second one is the limitation in computation. The way formal characters are computably connected to one another. Computation has inner limits that were clarified by Church and Turing in the 30s, when it was proved that there was no universal program that would computably predict in advance the behavior of any other program. So we have to keep this in mind. And there's one third limitation, which is a limitation in access. The way correlations are computably drawn becomes less and less reliable as data grows bigger. So that's something I would like to insist on, and I will only focus on the third type of limitation, that of access, which is directly relevant, I think, to data mining. So two mathematicians, one based in New Zealand, Christian Kalude and Giuseppe Longo from École Normale Supérieure here in Paris, have proven a theorem just a year ago. They describe this way. Our work confirms the intuition that the bigger the database which one mines for correlations, the higher the chance to find recurrent regularities, and the higher is the risk of committing fallacies. We showed that the overwhelming majority of correlations are spurious. In other words, there will be regularities, but by construction, most of the time, almost always in the mathematical sense, these regularities cannot be used to reliably predict and act. In other words, irrelevant correlations expand as the database grows. Relevant correlations are structurally outnumbered by spurious ones. As the two authors say, too much information tends to behave like very little information. From this point of view, the constant increase of computer power over the years is not necessarily good news, for it allows ever-increasing computation that leads to ever-increasing false correlations, and size in database is therefore important. Therefore, scientific models cannot be replaced by statistical algorithms in huge databases. Relevant regularities cannot emerge as if by a miracle in this deluge of data. So let's go now to productive justice. And what would be the relevant use of data mining in legal systems? I will end with only 3 points. The first point to be underlined is about the expression productive justice itself. Production cannot simply be identified with correlation, for correlation does not entail prediction, as these two mathematicians proved last year. It means that aggregating formal legal decisions cannot automatically lead to relevant future ones. The second point is that a legal decision cannot only derive as a computable consequence from a database, whether its size is small or large. A semantic judgment must be made. That is, a norm must be conceived as a revisable model, allowing the interpretation of facts, just like in science, from Galileo to Leibniz or to Newton. So the third point is therefore how to distinguish between predictable and non-predictable events in legal systems. And we tackled the problem many times today. Predictable events are computably repeatable because they can be formalized by means of rules without being interpreted through the mediation of a revisable norm. Predictable events are, in a way, temporally unidimensional. I mean, the past is somehow the same as the future, or the other way around. But non-predictable events, and I think like decision-making, require to be interpreted through a revisable norm precisely because these events can modify the norm through which they are interpreted and make it evolve. So past and future are conceived as essentially different in that case. And it is through these non-predictable events that legal systems are both normative and historical. So as a conclusion, I would just say that big data, as they are now used, cannot be dispensed of course. And I don't want to give the impression that we should go back to the good old days when encyclopedic knowledge was dealt with by hand. On the contrary, the main issue today is to ponder on the difference between computable and non-computable processes in the legal sphere and to imagine new ways to hang them together. Thank you.